Okay, I'm recording. Just want to give you guys a heads up. You guys got real quiet. Well, I don't really know who and subscribes to my my channel. So in case you guys talk about other classes and stuff, I want to make sure that there's nothing in the background that you guys may not want to get picked up on. I know. I'm trying to get to 100, guys. I'm 24 away. So if you guys don't subscribe to it, even if you guys don't watch it, please subscribe. I want to get to at least 100. I don't know if you guys subscribe or not. It's not like Instagram where you can see. Yeah, but then what if you leave and then unsubscribe? You guys unfollow me. You guys follow to unfollow, huh? As soon as you graduate, you're in line for graduation, you're unsubscribe. Okay, this is a really important example because it shows you guys how things can get weird. Okay, so what I want you guys to read the directions. It says determine any values where the function is discontinuous. That also could mean that it's continuous everywhere. You good? Okay. So the easiest way to do this is you want to check. This is where I like to call the breaking points, where the function changes. So we're going to use this function, obviously, when x is less than -1. Use this function when x is greater than or equal to -1. Oh, sorry, just greater than -1. And if x does equal -1, it's just 5. Okay, so do you guys agree the only value I need to check is -1 because that's the number that's in all three pieces? Does that make sense? If you're doing something similar here, you'd have to check -1 and 2 because that's the only places where things change. Okay, and the reason why is because we can assume it's continuous everywhere else because do you guys agree this function right here is quadratic? Quadratics are the domain's all real numbers. So that's continuous everywhere. This is linear. So it's continuous everywhere. This is constant. It's continuous everywhere. But just where it breaks, things might happen. Okay? So to refresh your memories, in order to check if it's continuous, you have to see if f of the input exists. So do you guys agree I can plug in -1 into this function? And it equals 5, right? So step 1, does f of -1 exist? And the answer is yes. G of -1, I'm gonna fix it right now, is equal to 5. This is what I get for trying to be fancy and not call it f. What else do I need to check? The limit exists. So I have to check the left and the right. Right. Which one's the left, top or middle? Top, okay? So step 2, does the limit as x approach -1 of g of x exist? So to check that, the limit as x approaches -1 from the left of g of x is equal to, I can plug in -1 into here. Now, I'm not going to be obviously at your house watching you guys do your homework. That's weird. However, my advice is, I have no idea if you guys use a calculator for something like this. On your next quiz, what's wrong with me? Next quiz, you guys can't use a calculator for something like this. So practice using mental math. So parentheses, -1 squared plus 2 times -1 minus 1. What is -1 squared? 1. 2 times -1? -2. Minus 1. So this simplifies to -2. The limit as x approaches -1 from the right of g of x is equal to, which function do I plug this one into? Middle. So if I plug it into the middle, that's just -1 minus 1, which is -2. Are we happy? Yes, because what does that mean? The limit exists. So I could say, therefore, the limit as x approaches -1 of g of x is equal to -2. So it does exist. So check. Check. What's the last thing you have to check? I feel like I'm saying check a lot. Yeah. This has to equal what? The limit. And if it doesn't, that means what? It's discontinuous. Are they the same? Okay, so this is what I was trying to talk to you guys about while you guys are probably mentally checked out yesterday and ready to leave my class. Because it's just very possible this could happen, and I'll show you guys why. So step 3 is g of -1 equal to the limit as x approaches -1 of g of x. I'm going to put a big X because that's no. And then just for your notes, so you guys remember, g of -1 is equal to 5. And then the limit as x approaches -1 of g of x is equal to -2. Okay, so if you guys were listening to me yesterday, what does that mean about the graph that's happening? Is it a jump? Because remember, if a limit exists, does that mean it's approaching the same value from both sides? Is that a jump? No. No. Okay, so what does that mean? There's a hole. Okay? So, I drew this really pretty last year. I'm going to try to draw it pretty again. So let me show you guys what it looks like. You don't have to draw this. Just watch the magic happen. So this is what's happening. Do you guys agree the top function was quadratic, right? So what's happening is before -1, we have some parabola. And it's coming down like this, and it gets really close to which number? What's the limit? -2. So it's going to look something like this. And then at -2, it's going to stop. And then the middle function was linear, right? X minus 1. So then after that, it's going to be linear. So it's going to look something like that. Does that make sense? So this is -2. Pretend like that hole's at -2. My drawing's bad. Okay? But then we know that at -1, we have a point. That's exactly what's happening here. G of -1 gives us 5. You guys agree that for sure is a point. But because the limit and this aren't the same, can I draw a point there also? No, that's why it has to be a hole. So that's the type of discontinuity we have. So on your homework, it's going to ask you guys to classify this. So that means, therefore, there is a hole at x equals -1. Okay, questions? No questions? Did I explain it good? You guys following along what I'm saying? You guys are picking up what I'm putting down? Our flow of knowledge is continuous? Hey, what's up?
So we're going to see the jump now?
Jumps were yesterday, so because when the limits aren't the same, that's a jump. And then when you can't divide by 0, that means that's a vertical asymptote. So on these, it doesn't really happen too much because it's piecewise. Piecewise generally means holes or jumps. Lost my train of thought. I need more coffee. Okay. Now for one of my favorite type of problems we do in this class. Now, it's not hard, I promise. This is whenever I say a sticky note problem, will you guys know what that means? Okay, sticky note problem means put a sticky note in your notebook because this is super important. This for sure is almost always a multiple choice question on the AP exam. We're going to do a hard one, then we're going to do an easy one. Or no, sorry, flip that. We're going to do an easy one first, and then we're going to do a hard one. Let H be a function defined by h of x is equal to 2 minus x squared for x is less than or equal to negative 2, and then 4x plus k when x is greater than negative 2. What value of k makes h of x continuous at x equals negative 2, question mark. This type of problem is the last problem on your homework. So if you guys looked at it, you're like, what? What is it saying? Is that a mango dragon fruit refresher? Corelli. Is that a mango dragon fruit refresher? Nice. With limited or no? Nice. Is that sad that I know that? Also yes. Okay. You guys ready? This is a fun one. This is an easy one, I promise. Okay. The only thing that's weird about this is we have x's and we have a k, right? But if it's continuous, what I want you guys to think about is one of the conditions for continuity is what we know about the left side and right side limits. They must be the same. So if I want it to be continuous at x equals negative 2, that means when I plug in negative 2, wherever there's an x, this top function has to be equal to this function because that means they come to the same point. Does that make sense? On the graph. Okay? So I want you guys to make yourselves a little note and say, find k. So the left, if I write it this way, do you guys know what I'm saying? Left-handed limit. You guys cool if I write it like that? Left-handed limit and the right-hand limit are equal when x equals negative 2. Now this is the part where students always forget. They give us that piece, that means you want to plug in negative 2. So the top, the left side limit would be 2 minus x squared. We want that to be equal to 4x plus k. But I need to plug in what? Negative 2. So wherever there's an x, I'm going to replace it with negative 2. So this becomes 2 minus parentheses negative 2 squared is equal to 4 times negative 2 plus k, then this becomes pretty easy. What is negative 2 squared? 4. What is 2 minus 4? Negative 2. 4 times negative 2 is negative 8. Last step. Add 8. So what's k, guys? That's it. Is that a hard question? But think about it. Between now and May, aren't you guys going to learn a lot of different calculus techniques? So this is something that we have to make sure we don't forget in May. So if you guys are worried about something like that, we're going to do a lot of MCQ practice and a lot of FRQ practice. And then I have like a review packet I'll give you guys too, like a month before the AP test that covers like all the important things. Questions on A, because it's going to get harder. Yes, sir. So remember, like if the limit is the same, that means from both directions, because that's where the function would break, right? So because this is where it breaks, you would, if you were trying to find the left-handed limit, if that was like 3, you would plug in -2 into here, -2 into here, and try to see if they're the same. So that's why I was able to just plug it in. Okay. You guys ready for the new one? You good? Okay. You're like deep in thought. All right. Don't hate me, guys. Nice. Can you guys make sure your phones are on silent, please? Thank you. Oh. Must be. Imagine it's me. Now, the reason why I highlight that in blue is because this one's a lot harder. This could possibly be like an FRQ type question. Or maybe like extra credit on your first test or something. All right. So far, hopefully you guys haven't felt like things are too difficult. This one also isn't too difficult. It's just long. And the reason why is because how many pieces do we have this time? 3. How many variables do we not know? Technically 3, right? But they're asking me to find A and B, right? So I have to find 2 this time. So what I want you guys to understand is if it's continuous everywhere, remember I told you guys to find if it's discontinuous, you look where the function breaks, correct? Where does a function break? Here. 2 and where else? 3? Okay, so if it's continuous, what do we know about the limits? They should be the same. So we have to show that the left-sided limit is equal to the right-sided limit when x is equal to 2. And we also must show that the limit from the left at 3 is equal to the limit from the right at 3. You guys follow me? So I have to do 4 limits before I could even find A and B. So watch. You guys ready? Okay. I would not make you guys do this on a test. I will, you guys listening? Something like this for sure will be on your first test because this is super important. Okay. So, do you guys notice something I can do first before I do anything? What can I do? Hey, this factors. Hooray. So let's do that first. Okay, so I'm going to rewrite it. So k of x is equal to x plus 2, x minus 2, all over x minus 2, if x is less than 2. And then we have ax squared plus bx plus 3. Almost wrote c by accident. And then 2x minus a plus b when x is bigger than or equal to 3. Okay. So what can I do, guys? X minus 2's cancel. Okay. So this is a college level math class technically because it's AP. So what I want you guys to write down is, I think I've shown you guys this before. That means we must show that the limit as x approaches 2 from the left of k of x is equal to the limit as x approaches 2 from the right of k of x, and the limit as x approaches 3 from the left of k of x is equal to the limit as x approaches 3 from the right of k of x. Okay, so nothing new so far. What's going to be new is, what do we do with our results? So, the limit as x approaches 2 from the left of k of x, let's find that first. So we already factored this, right? I see a lot of you guys writing. I want to make sure I'm not going too fast. Do you guys agree I'm going to use the top function for the left side of limit at 2? So we already know this cancels, right? So do I have to worry about this anymore? So if I'm going to plug in 2 from the left, all I have to do is plug in 2 right there. What's 2 plus 2? 4. Okay. Now the limit as x approaches 2 from the right of k of x is equal to. Now here is where things get weird because I have a's and b's, right? But where am I plugging it in for? Which letter? X. As x approaches 2, that means I'm going to plug in a 2 in for each x. So I'm going to have a times 2 squared plus b times 2 plus 3. 2 squared is 4. 4 times a is 4a plus 2b plus 3. Is everyone cool so far? Now, this is where things get confusing. Please stop me if you're confused. We're trying to show that these are the same, right? But do you guys agree the issue is I have 2 variables I don't know yet? Okay? We're going to get there. But if these are equal, do you guys agree that means I can say that 4 is equal to all of this garbage? So this means that 4 is equal to 4a plus 2b plus 3. Now, because I know things, I want all the a's and b's on one side, and I want to kick this 3 to the other side. So I'm going to subtract the 3 from both sides. So I'm going to have 4a plus 3. Is it 2b or 3b? 2b. Or not 2b. 2b is equal to 1. I'm always tempted to say that, and then I always feel lame afterwards and embarrassed. You guys have read Shakespeare, right?
Yeah.
Okay. If you say no, you guys are lucky. Shakespeare's terrible. I hate it so much. Don't tell Miss Jones. Okay. I'm sure she doesn't like math either. It's fine. Are we good so far? Okay. What are we going to do with this? Stay tuned. But now let's do the limit when x approaches 3. I'm going to slide this over. I'm going to draw a little wall so you guys can separate, or you can see what I'm doing. So now the limit as x approaches 3 from the left of k of x, which one am I going to plug that into? Middle, good. So it's going to be a times 3 squared plus b times 3 plus 3. So that's just going to be 9a plus 3b plus 3. From the right, I'm going to plug it into the bottom. So it's going to be 2 times 3 minus a plus b, which is just 6 minus a plus b. Okay, so now, if this is continuous, do you guys agree that the limits have to be the same? So even though I have weird expressions right now, we want to set those equal to each other. So I want 9a plus 3b plus 3 to be equal to 6 minus a plus b. Okay, so now, and you guys will see why here in a second, just like I did over here, I want to move all the a's and b's on one side and move the constants to the other side. So do you guys agree I could add a to both sides and subtract b from both sides? And then I'm going to move this 3 over there. So if I do that, I'm going to get 10a plus 2b is equal to 3. Okay, so we've actually done the limit part already. The last step is to find a and b, right? So, you guys are in calculus. I have 2 equations with 2 unknowns. I have to solve this system of equations by using either substitution or elimination or a matrix. No, we're not going to use a matrix. Okay. So interestingly enough, for those of you guys that took the college pre-calc class last year, matrices is an AP pre-calc, but AP pre-calc, has an optional unit, and that's in there. But when you guys hear optional in life, what does that mean? Don't do it. So we're not going to do it. It's not on the AP test, so I don't want to put them through that. Okay, do you guys see how these are the same? So what I could do is just multiply this by -1, so that way the b's will cancel. So I'm going to multiply the top line by -1 and just write it underneath. So I'll get -4a minus 2b is equal to -1, and then I'm just going to add these lines together. So I'm going to get 6a is equal to 2. Is everyone cool with where that came from? Divide both sides by 6. Two over 6 reduces to 1/3. Okay. Now I need to plug it back in to find b. Does it matter which one I plug it into? No. So I'm going to say 4 times 1/3 plus 2b is equal to 1. 4 times 1/3 is 4/3 plus 2b is equal to, I'm thinking ahead. I'm going to eventually need to subtract this from both sides, right? So I'm going to write this as a common denominator already to make my life easier. Do you guys agree that 1 is the same thing as 3 over 3? Okay. So if I subtract 4/3 from both sides, I'm going to get 2b is equal to negative 1/3. Oh, fractions. Divide this by 2. That's the same thing as multiplying this by what? 1/2. So b is equal to negative 1/6. Okay. I promise I would not give you guys this on a test, but you guys see how this works. This sucks. This is a lot of work.